Hi, so in this video, I'm going to talk a little bit about the binary number system or base 2 number system. Okay, so first of all, why do we use binary base 2 when we in computer systems? Okay, well, first of all, binary, or also bit, means binary digit. It's one of two discrete values. Okay, we represent those as binary values 0 and 1, base 2 numbers 0 and 1. And we normally think of these as off and on, two discrete states. So that's all bits are. They're one of two discrete states. Not typically off and on, but they can, that's how we think of it, or can be off and on. But as and when we look at sometimes a switch on a device, sometimes it's even represented as a 1 and a 0, off and on, even like this. We have a 1 and a 0. Kind of cool. All right, but bits, I said, can be one of two discrete states. It's either this or that, off or on, negative or positive, true or false, one state or the other. Now, why do computer systems use bits, use one of two discrete states? Well, there's various reasons for this. But one of the reasons I like to talk about with students is, what if we had a system that had more than two states? Maybe we had a system that had four different states. Well, one of the issues that we have when transmitting anything between within one place to another, this could either happen internally potentially within the chips or circuit boards, but definitely over networks. If we had four different states, if I was sending you, think of it like a light. I was sending you a beam of light, either off, low beam, medium beam, or high beam. By the time it sent you, maybe I meant to send you a very high beam, but the time it reached you, you're seeing it as a medium beam. So that actually changes the value. If we have one of two discrete states, let's say I'm either sending you a light or not sending you a light, okay? As long as you can see that light, these signals attenuate, meaning over distance, a signal weakens. So even though this signal weakens, you still see that signal. So although it's weakened, we're still, I'm sending you a on, you see the light, and I'm sending you at a certain level, you still see it, although it's weakened. Now, of course, if the distance is too great and that signal weakens enough where you don't see it, then of course you're not going to be able to, the value is going to change. This is why we have certain limitations, cable length, how far away you can be from a cell tower or a wireless access point, etc. Okay. All right, so let's talk about binary and decimal. First of all, decimal. We said decimal is base 10, okay? 10 different values starting with 0, 10 digits starting with 0, okay? Binary has 2 digits starting with 0. Both of these have the rightmost column of ones, the number of ones. Every column after the column of ones in base 10 is 10 times the previous column. In base 2, it will be 2 times the previous column. We're going to see this in more detail here in a moment. Now, what can go in each of these columns is any of the values, the symbols of that number system. So in base 10, we can use any values 0 through 9. Base 2, we only have 2 digits to work with. 0 or 1. That's it. All right, let's get into this. And this will make more sense as we convert from binary to decimal and decimal to binary. Okay, counting in binary. How do we do that? Okay, remember the same rules that we had before. First column, column of ones, and then every column after that is 2 times the previous column. And I'm stopping at 128 here, but I could keep on going at 256, 512, 1024, etc. Okay, excuse me. Let's convert our counting in binary to the same as counting in decimal. A 0 in decimal is a 0 in binary, okay? That's our first digit, okay? When I increment in decimal, I go from 0 to 1. Same thing in binary. I still have another digit, 1. So these are equivalent. Okay? Next, in decimal, I have another value. When I increment by 1, I go from 1 to 2. Well, in binary, remember what we talked about previously? When we reach the end of our values in our number system, what do we do here? We put a 0 here and increase the next column by 1. I'm going to see how this works really nicely here in a moment. Okay, you might even be able to see, how many 1s do I have? How many 2s do I have? Oh, it kind of equates to 2, doesn't it? All right, let's increase this again. 3 in decimal. Well, I'm going from, can I always, increment this column first? 0, yeah, I've got room. Go from 0 to 1. Let's put a 1 there and just bring this down here. Okay, so 1, 1 is equal to 3 in decimal. Just like 1, 0 is equal to, in base 2 is equal to 2 in decimal, and 1, 1, and 0, 0. Those are all equal. Okay, I have 1, 2, and 1, 1. Hey, that would give me 3, wouldn't it? We'll get there in a moment. How about 4? Uh-oh, let's see. Oh, I'm out of 1 here again. What do? Oh, yeah, when I'm at the end of my digits in my number system, I got nothing else here. What do I put here? Remember? Just like when we go from 9 to 0 in base 10, in binary, same thing. We're at a 1. We're at our last value. Let's put a 0 here. Then increase the next column by 1. Oh, how do I increase this next column by 1? I'm at 1. Same rule. We're at the last digit in our number system. We got to increase this by 1. Put a 0 there. And increment the next column by 1, which goes from nothing or 0 to 1. Now I have 1, 4. Nothing in the 2s column, nothing in the 1s column. Okay, and if I was going to do 5, I would just increment this 0 to a 1, bring these down, 0 to 0, 1 to 1, and I'm good there. Now, this is going to make more sense when we do the conversions. All right, let's get started. All right. Forgot one little thing here I wanted to mention. So if we look at this, this is how many 1s I have, how many 2s I have, how many 4s I have, how many 8s I have. No different than a decimal number system, except in decimal, this is how many 1s, 10s, hundreds. That's how we do those columns. So how many 1s do I have? I have 1, 1. That's 1 decimal. Okay, how about here? I have 1, 2, and 0 1s. That's a 2 in decimal. How about here? I have 1, 2, 1 in the 2s column, and 1 in the 1s column. That's a 3. This is going to make more sense here in just a moment. Okay, so let's look at this. Remember, in these columns, all I can put is a 0 or a 1. That's all that can go in here. Our first column is a column of 1s, and every column after that is 2 times the previous column. So 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, etc. All right, if I was going to convert from binary to decimal, okay, what do I do? All right, well, think of it like this. Think of these as some kind of binary bills, some kind of monetary number denomination. I can give you a $1 bill, a $2 bill, a $4 bill, an $8 bill, and I'm not giving you any of these. I give you 1 of it or 0 of it. Okay. Well, if I give you an $8 bill, I can give you 0 or 1 of it. I'm not giving you any $4 bills, no $2 bills. I'll give you one $1 bill. I'm giving you 8 plus 1 is 9. It's that easy. That's how you convert from binary to decimal. Just add up wherever you have a 1, add up what that column represents, what position it's in, and that gives you the decimal number. Let's take a look at these. If you are one of my students and you see this number here, okay, that means you get to put that in your homework assignment. Don't forget to do this. All right, if you're not one of my students, let's follow along anyway. All right, so let's do number 1 here. These zeros here don't matter. Okay, don't have any, and don't have any 1s prior to this number here. We have 1, 4. I gave you a $4 bill. I gave you a $2 bill. Didn't give you any $1 bills. So 1, 1, 0 in binary is equivalent to 6. 1, 4, 4 plus 2, 6. Now, do you have to write these leading zeros? No, you do not. If they're all leading zeros, you don't have to write them. Okay, so 1, 1, 0 is at a minimum what you have to provide. Let's look at number 2. Okay, oh, I've got a 1 way over here. Let's not forget that. I gave you a $128 bill. I didn't give you any 64s, no 32s, no 16s. Oh, I gave you an $8 bill, so let's add that. Oh, I gave you a $4 bill. Let's add that. And I gave you a $1 bill. Let's add that all together, just where we have the ones. And what do we get? You got it, 141. How about number 3 here? Let's see, 0 and the 128. So I don't need that 0 there, but I do need that first value here, the first 1 value I have. And again, I need these trailing zeros here, okay? That moves everything, puts everything in the right position. Okay, give you a $64 bill, an $8 bill, and a $4 bill. 64 plus 8 plus 4. It's all the ones I've got, right? What does that equal? 76 in decimal. So this is the binary equivalent, the base 2 equivalent to 76 in decimal. If I said, I'm going to give you 1001100 base 2 apples, that's the same number of apples as if I said I'm going to give you 76 base 10 apples. Same number of apples. Okay, how about this one? We have a 1 here. I think you're getting the idea here, and a 1 here. Then the rest are all zeros. So this number 11000000 in base 2 binary is equivalent to 192 in base 10 decimal. Let's do another one. Oh, got a little adding to do here, right? 128 plus 64 plus 32 plus 16. I think that's it, right? Add those up, 240. All right, let's go decimal to binary now. Let's go, it's exactly the same, only different. All right, what if I gave you the number 14 decimal? How do we convert that to binary? Okay, let's take a look. Let's look at it like this. I owe you $14. Okay. And I can give you a $128 bill, a $64 bill, a $32 bill, a $16 bill, $8 bill, $4 bill, $2 bill, or $1 bill, and or any of these. But I can only give you one of them or 0. If I owe you $14, am I going to give you a $128 bill? No. Okay. And I owe you that much. How about $64 bill? No, I'm not going to give you that. $32 bill? No. $16 bill? No. How about an $8 bill? Yes. Okay, because I owe you 14. But now, you know what? I no longer owe you 14. I'm going to subtract the $8 I gave you, and I owe you $6. Now, I owe you $6. Am I going to give you a $4 bill? Yes, I will. Okay, so subtract the $4 I just gave you from the $6 I owed you. I owe you $2. I'm going to give you a $2 bill. Yes, I will. Remember, 1 or 0. That's our only choices. Okay, I'm going to give you one of the $2 bills. Subtract that. Now I don't owe you anything. Am I done? No, not done as far as writing it out in base 2. Don't forget that 0 here. So that makes sure that these ones here are in the proper position. Okay. Now you can double check yourself from what we just learned previously. Wherever we have a 1s in those columns, add those up. 4 plus 2, 8. 8 plus 4 plus 2 equals 14. Okay, that was number 6. Let's go to number 7. I owe you $18. Now, some of these you can kind of eyeball. What am I going to give you one of? Okay, but let's go through this. I owe you 18. I'm not going to give you a $128 bill. I'm not going to give you a $64 bill. I'm not going to give you a $32 bill. Am I going to give you a $16 bill? Yes. Okay, because that'll help. Give you $16. Now what do I owe you? Subtract the 16 I gave you from $16 bill I gave you from the $18 I owed you. I owe you $2 still. Am I going to give you an $8 bill? No. Don't forget the zero there. Am I going to give you the $4 bill? No. $2 bill? Yes. So let's subtract $2 from the $2 I owe you. I owe you $0. Don't forget to put the zero there. Double check ourselves. Let's add 16 where we have the ones. Add 16 plus 2. That's 18. How are you doing? All right. Let's take a look at 130. Excuse me. Might look a little, excuse me. This may look a little scary. 130, what do I owe you? Let's see. I'm going to give you, first of all, is there something beyond 128 I'm going to give you? No, think of the next column. What's the next column? Every base 2, every column is 2 times the previous column. So the next column would be, you got it, 256. I'm not going to give you 256. So we know there's going to be 0 here, nothing here. Okay, am I going to give you a $128 bill? Okay, well, I owe you 130. Yeah, $128 will help. So I'll give you a $128 bill there. Now I only owe you 2. Well, we can eyeball this, right? Not going to give you any of these. Get all the way down to 2. I'll give you the $2 bill. Subtract that. I owe you nothing. Okay, we can double check. 128 plus 2 equals 130. Don't forget the 0 here. 192. Well, we saw this going the other way before. But this here, again, owe you 192. 256 would be too much. So we know we don't have this column over here. 128. Okay, let's give you a $128 bill. Now I owe you 64. Well, that's kind of easy. I'm going to give you a $64 bill. Now I don't owe you anything. Don't forget these zeros. All the way across. Okay, because I don't owe you anything. Again, 128 plus 64, 192. Okay. If you need to look at these more closely, pause the video. Okay, look at the examples again. Uh-oh, Rick gave us a tough one here. Well, not really tough, as long as we know how to subtract, right? Okay, I owe you $246. Again, 256 is this column to the left of 128. So we know that would be too much. Again, give you $128. Yes, I will. So let's subtract that. Now I owe you 118. So as long as your subtraction is correct, it's not a problem. Okay, I owe you I owed you 246. I gave you a $128 bill. Now I owe you 118. I'm going to give you a $64 bill. I will. So let's subtract that. I now owe you $54. And I'm going to give you a $32 bill. Yes. So let's subtract that. Now I owe you $22. Okay. So that's what I owe you now. Okay. Am I going to give you a $16 bill? Yes, I am. So now I owe you $6. Starts to get easier now, huh? Am I going to give you an $8 bill? No, I don't owe you that much. Let's see. So I'm going to put a 0 here. Let's go to the next column. I'm going to give you a $4 bill. I will. So let's, from the 6 that I owe you, I just paid you another 4. Now I'm down to $2. Okay, we're going to give you a $2 bill. I am. So let's subtract that from the 2 I owe you. We're back down to 0. Don't forget the 0 there. Again, just add up wherever we have the ones in those columns. That will give us 246. Okay, one more that's not actually for my students on the homework, but I realized I gave you a lot of even numbers after I did all this. So let's do one with an odd number. I owe you $49. Okay, I'm not going to give you 128, not going to give you a $64 bill. I will give you a $32 bill. Okay, so I owed you 49. I just gave you a $32 bill. Now I owe you 17. Am I going to give you a $16 bill? Yes, I am. So I owed you 17, just gave you 16. Subtract that. Now I owe you $1. Okay, so am I going to give you an $8 bill? Nope. $4 bill? Nope. $2 bill? Nope. $1 bill? Yes, there's our one. All right. Put a 1 in the ones column, subtract that. We have a 0. If I add these up, 32 plus 16 plus 1 gives us 49. Now, something I want to mention. If the decimal value is odd, you will have a 1 here. Okay. If the decimal value is even, you'll have a 0 here. Think of it like this. Notice that all these values are even. So the only way to make it an odd value is put a 1 here. Okay, if you want to keep all your ones here, whatever you have as far as ones, keep it even, you leave it as a 0. Okay. Anyway, just a little something to think about there. All right, so that's binary. Next video, we'll talk a little bit about hexadecimal.